Hello everyone, welcome back to my channel. This is the ninth part of the lesson called hyperbolic function. In the next video, either we will do some questions based on this topic or we will start a new chapter. So in this video, we will discuss about the formulas called some special formulas of hyperbolic functions. So for those formulas, we have to prove those formulas in this video. So the first one is given integration of 1 upon root over x square plus a square dx, which is equals to sine hyperbolic inverse x by a plus c. So for this we will use the left hand side value, which is given integration of 1 upon root over x square plus a square dx. So we have to consider it as I value. So after considering, we will use the substitution method. So we will use the substitution method to substitute the value of x dx. So first, if you see in the right hand side, we have sine hyperbolic inverse. For that, I have taken x value as a sine hyperbolic alpha, and then for this I can change it as x upon a sine hyperbolic, then which is equals to alpha. For that I have written alpha is equals to sine hyperbolic inverse x upon a. Then here we have to do the derivative. So differentiate with respect to x. So the derivative of x will be, since we are doing with respect to alpha, so dx upon d alpha, which is equals to derivative of a sine hyperbolic alpha, means a is a constant value and this value will be cos hyperbolic alpha. Then now change this d alpha to the other side because we have to get the dx value. So after getting the dx value, we have to substitute the values here. So if you see, we got the dx value and then the x value. Now substitute the values. So after substituting, we get integration of, see here, dx value is nothing but a cos hyperbolic alpha dx. Sorry, d alpha. Then integration, in the denominator part it is given x square, means the x value is nothing but a sine hyperbolic alpha, that is a square sine hyperbolic square alpha plus a square. Then after changing this, I have taken the a square as common and I have used a formula called cos hyperbolic square x minus sine hyperbolic square x is equals to 1. Here I have in the alpha form and it is given 1 plus sine hyperbolic square alpha. So 1 plus sine hyperbolic square x is equals to cos hyperbolic square x. So that's what I have written in this step as cos hyperbolic square alpha. And if you see here, root over of a square is equals to a, because these two values will cancel out. And similarly here also the root over of cos hyperbolic square alpha is equals to cos hyperbolic alpha. Then in this step it is given as integration of cos hyperbolic alpha upon cos hyperbolic alpha dx. So on cancelling, we get the value as 1. Then integration of 1 dx is equals to, not dx, it is alpha. There is a mistake, minor change, kindly change it out. So here it is in the alpha form. So alpha plus c. Then I got the value as alpha plus c and I have substituted the value of alpha as, if you see here, alpha is equals to sine hyperbolic inverse x upon a. So here I got the alpha value as sine hyperbolic inverse x upon a plus c. So this is the first formula. Now the second one is given integration of 1 upon root over x square minus a square dx is equals to cos hyperbolic inverse x upon a plus c. So for this we have to take the x value as a is equals to cos hyperbolic alpha. Since it is in the right hand side, it is given as cos hyperbolic inverse. So I have taken the x value as a cos hyperbolic alpha. And then I can change this value to alpha, and I get alpha is equals to cos hyperbolic inverse x upon a. Now here in this step we have to do differentiate with respect to alpha. Then dx upon d alpha is equals to d upon d alpha a cos hyperbolic alpha. So a is a constant value and the derivative of cos hyperbolic alpha is sin hyperbolic alpha. And here I got the dx value as a is equals to sin hyperbolic alpha d alpha. By changing the value, that means the d alpha has been multiplied here. Then just substitute the values. If you see here, I is equals to integration of dx is nothing but a sin hyperbolic alpha d alpha, and then integration in the denominator it is given root over x square minus a square. So the x square value is nothing but a cos hyperbolic alpha, that means a square cos hyperbolic square alpha minus, so a square as I have written in the, as I have considered as constant, so I have written here. Then again the same procedure, take the a square as common and then we can cancel out, that means a square is equals to a only. And again I have used the formula called cos hyperbolic square alpha minus sin hyperbolic square alpha is equals to 1. Here it is given cos hyperbolic square alpha minus 1, then cos hyperbolic square alpha, here the 1 will come this side, and which is equals to sin hyperbolic square alpha. So I have to substitute here at the value as sin hyperbolic square alpha. Then these two values will get cancelled out, that means sin hyperbolic square alpha root over, so these squares will get cancelled out and the left out will be sin hyperbolic alpha. Then in the next step I just cancel out the values, that means integration of sin hyperbolic alpha upon sin hyperbolic alpha d alpha. On cancel outing I got integration of 1 d alpha, so which is alpha plus c, and the alpha value was cos hyperbolic inverse x upon a. So this is what we got the next formula. So as I have proved here, integration of dx upon root over x square minus a square is equals to cos hyperbolic inverse x upon a plus c. Now we will go for the third formula. It is given integration of 1 by a square minus x square dx, which is equals to half ln mod of a plus x upon a minus x plus c. Now again I have to consider the left hand side value as I. So after considering here, I have taken as a minus x and a plus x will be equal to, which is nothing but a square minus x square only. So I have written this a square minus x square as a plus x, a minus x. Then if you see here, I just multiplied 2a and divided 2a. In this step I have let's write like this: multiply and divide 2a. So after multiplying 2a and dividing the 2a value, I can write this 2a as a plus x and plus a minus x. That means here the plus x minus x will get cancelled out and the remaining will be 2a. So for that I have written a plus x plus a minus x. Then just split it out the values, that means a plus x upon a plus x, a minus x plus a minus x upon a plus x, a minus x dx. So if you see here, a plus x and a plus x will get cancelled out and the remaining will be a minus x, that means 1 upon a minus x. And similarly here also a minus x will get cancelled out and the remaining will be 1 upon a plus x. Now take the integration individually, that means 1 upon 2a and the integration of 1 upon a minus x dx plus integration of 1 upon a minus x dx. So I have just written the positive value first and then the negative one. So on integrating this value I got 1 upon 2a ln a plus x since it is in the minus form, minus ln a minus x plus c. Then when the ln is in the form of a plus x minus ln of a minus x, then I can write this one as ln of a plus x by a minus x mod of c. So this is the third formula which we have proved out. And the next formula of special hyperbolic functions formula is integration of 1 upon x root over a square minus x square dx, which is equals to minus 1 upon a sec hyperbolic inverse x by a mod of c. So as I have done the previous questions, here also for the left hand side value I just taken I, which is equals to integration 1 upon x root over a square minus x square. And then here I have taken, since here it is given in the sec hyperbolic inverse, so I have taken the x value as a sec hyperbolic a beta, any kind of variables. That means so I have taken a beta, and then here I have done differentiating with respect to beta. So dx upon d beta, which is equals to d upon d beta a sec of a beta. Then dx upon d beta, which is equals to, so if you see here, a is a constant value and the sec hyperbolic a beta value is minus sec hyperbolic a beta into tan hyperbolic a beta. Then the derivative of a beta, which is nothing but a, since a is a constant value, so I have written as minus a sec hyperbolic a beta into tan hyperbolic a beta into a. So on arranging this one, that means which is equals to minus a into a is nothing but a square sec hyperbolic a beta into tan hyperbolic a beta. So we got the dx value as minus a square sec hyperbolic a beta into tan hyperbolic a beta into d beta. Now we have to substitute these values. That means the value of x and then dx we have to substitute in the I. That means integration of 1 upon x root over a square minus x square dx. So the dx value, which is nothing but minus a square sec hyperbolic a beta into tan hyperbolic a beta d beta. Then x is nothing but the value is a sec hyperbolic a beta root over a square minus again the x value, which is a square sec hyperbolic square a beta. Then if you see here, the minus will be removed outside of the integration, and then here it is integration of, here I have taken the a square as common again. After taking the a square common, I have written as a square multiple of 1 minus sec hyperbolic square a beta into, and this value which is sec hyperbolic a beta d beta. Then these two values will get cancelled out here, because in this step I just cancel out the a value and again here from 1a, then the remaining will be only minus a. Again from here I have taken the a square as common, then which is nothing but a upon a square. So on cancel outing I got a upon a, which is 1. So in the next step, if you see, the sec hyperbolic a beta and here also sec hyperbolic a beta will cancel out, and the remaining will be integration minus integration of tan hyperbolic tan, let me write correctly. So tan hyperbolic a beta upon root over 1 minus sec hyperbolic square a beta. So by the important identities we have a formula. So by using that I got the value as root over tan hyperbolic square a beta. So on cancel outing I got the value as d beta. So beta is integration of d beta is nothing but beta plus c, and the beta value was, here we got, that is beta value is nothing but if you see here, after changing this value, I got the value as minus 1 upon a sec hyperbolic inverse x by a plus c. So this is the fourth formula of special formulas of hyperbolic functions. In the same way, you have to do for the fifth formula, that means integration 1 upon x root over a square plus x square dx, which is equals to minus 1 upon a cosec hyperbolic inverse x upon a of mod c. So if you see here, since it is in the sec hyperbolic inverse, I have taken x is equals to a sec hyperbolic a beta. Similarly, in the next formula, we can take x is equals to a cosec hyperbolic a beta. So on using that, you can solve the next formula. And the last one is given integration root over a square plus x square dx is equals to x upon 2 root over a square plus x square plus a square by 2 sine hyperbolic inverse x by a plus c. So similarly, we have to take from the left hand side value, but in this case we have to consider one more value function, that is 1. So on considering that, we can use the method called, that means integration of uv, that is integration by parts value, which is nothing but integration of uv dx is equals to u integration of v minus whole integration of d upon dx u multiply of integration of v. So this is what we have the partial derivative integration formula by parts, integration by parts formula. So this is, by using this, we have to solve I is equals to integration of root over x square plus a square 1 dx. Then so this is our u value and this is will be our v value. So on solving those values, we get the value of I as x root over x square plus a square minus integration of root over x square plus a square dx, plus as a square as a is a constant value, so on taking a square, integration of dx upon root over x square plus a square. Then I is equals to, so this is the part of I. If you see the formula, so as I have taken I is equals to integration of root over x square plus a square 1 into dx. So I have taken this part as I plus a square into, so this is our sine hyperbolic inverse x upon a plus c, a constant value. Then on changing this I to the other side, we get 2I is equals to x root over x square plus a square plus a square sine hyperbolic inverse x upon a plus c. Then this 2 will come to the other side and I can write it as I is equals to x upon 2 root over x square plus a square upon 2 sine hyperbolic inverse x upon a plus c. So this is the last part of hyperbolic functions. In the next video, either I will start a new topic or we will do the some of the that means questions to practice this topic. So that's it for today. Thank you.